Welcome to solverfy.
Okay, so we're shown several structures here. The first I will draw here. Got an amide. An amide is just a carbonyl neighboring an amine, essentially. Okay, and I'll add the lone pairs here. Okay, next structure. We've effectively reorganized the molecule, basically just shifting the double bond and the lone pair. Shifting this lone pair into this bond and this double bond up onto oxygen. But overall, it's still a neutral charge. We have a positive nitrogen and a negative oxygen. Next, we now have a protonated oxygen. It's basically almost like an alcohol. We have a lone pair on this nitrogen. And then our final structure is like so. I need to clean this up because that's not a negative charge. Okay, and we're asked to identify which of the following represents a conjugate acid-base pair. Now remember, this might seem very complex, but at the end of the day, what defines a conjugate acid-base pair is that your acid, which I'll write A bonded to H, right, has a proton, and the conjugate acid has lost that proton and has a lone pair and a negative charge in its place. Right, so we're really just looking for a set of molecules here in which we've lost a proton. Right, you can identify that they're the same structure, except for one has one less proton and it has a negative charge, whereas previously it were neutral. Or maybe you go from a positive charge to neutral. But the important thing is that the charge decreases by one when moving from the acid to the conjugate base. Okay. So which of these, do any of these look like it's lost a proton, right, relative to any of the others? Well, I will point out that if we call this A and the second one B, the third one C, and the fourth one D, the A, B, C, and D all have total neutral charges, right? They don't have a net charge. All the atoms here are neutral. Here there's one negative atom and one positive one. And in C we have, again, just a set of all neutral atoms. But in D, we do have a negative charge, right? And that's going to happen if we pull off H plus and leave behind a lone pair, right? So if anything's the conjugate base of an acid, it's D, right? D is our only candidate that could be a conjugate base for any of the other molecules we have. But as it turns out, D has a really clear connection with A, right? If you'll notice, everything in A looks exactly the same as everything in D, with one exception, right? In A, we have a bond to a proton on the nitrogen, and in D, instead, we have a lone pair. That's exactly, and a negative charge. And that's exactly the relationship between an acid and its conjugate base. You lose a proton, you gain a lone pair and a negative charge. We've lost a proton, we've gained a lone pair and a negative charge. So A and D would be your conjugate acid base pair.